I'm Tom Ryder. I'm with Genesis Plastics Welding, and I'm here to talk today about replacing polyurethane and PVC in radio frequency welding of thermoplastic materials. Before I get started, though, I'd like to ask you guys a couple questions. And it helps me in who I'm speaking to. So first of all, can everybody in the back hear me okay? All right. By the way, Century Spring and Accurate Screw, I'm sorry, I appreciate it, but everybody, whoever needs springs and screws, go back there and talk to them because they've been harassed all week. So, thanks guys. I want to ask you guys here in the audience, of everybody here, who's familiar with radio frequency welding of thermoplastic materials? By a show of hands, please. Okay, great. I'm assuming that most of you understand what plastics are. Of you, who, by a show of hands, are familiar with the difference between polar and non-polar plastics? Okay. So I'm gonna try and keep it at a certain level that's of an understanding for the majority. Feel free, if you have more technical questions, to come see me after the presentation, or stop by our booth to get more clarification, because there's a lot more details that can be shared with you. So I'd like to get started with an overview. First, we'll start with Genesis, our company, just a little bit. We'll talk about plastic sealing and the type of plastics that we're going to be working with in the different heat sealing devices. We're going to talk about the limitations of heat sealing methods. We're going to talk about why would you use radio frequency over other processes. And we're going to talk about why eliminate PVC and polyurethane. And then we're going to talk about how to eliminate that in RF welding, which is what you're here for. I need another question. Any of you guys selling PVC or polyurethane? Okay, makes my job a little easier. I don't want stones being thrown at me for this. Nothing against PVC and polyurethane. We use it in our contract manufacturing process all the time. About our company, Genesis Plastics Welding, we are a contract manufacturer. Our primary work is in radio frequency. We do use ultrasonics and heat sealing in our contract manufacturing business, but our expertise is in radio frequency welding. We actually employ a proprietary technology called Ecogenesis. Ecogenesis is something that we can add to any RF system that allows us to take PVC or polyurethane off the machine and put polyethylene or polypropylenes or other non-polar materials on the machine. We are an FDA registered facility. We have a class 7 clean room, or class 10,000, depends on what angle you're looking at. And we also take our Ecogenesis and license it to other customers who have an abundance of RF machines that are processing product in their facility. The materials that I want to focus on, because plastics is such a broad range, and there's just so many different types of plastics. You have rigid plastics, you have soft plastics. I want to focus in to make sure that everybody understands that what we're speaking of when we're speaking of in the radio frequency land, the most commonly used materials are thermoplastics, and they're in a range from 2 mils to 60 mils of thickness. Within thermoplastics, I want to separate that into another 2 categories. Again, some broad categories. If you're a plastics technician or engineer, you're going to know a lot more than I am, but I'm trying to keep it at a broad level. There's polar and there's non-polar materials. Polar materials are very commonly known. I mean, PVC and polyurethane are some of those polar materials, and that's really the widely used materials, especially in the RF welding world, but very much so in the medical contract manufacturing world. Outside of polar materials, you have non-polar materials. Materials that are in the non-polar category are like polyethylenes, polypropylenes, as well as PETs, and some varieties of things that just make up an abundance that I can't even list all those that are out there. With welding or heat sealing of plastics, there's a lot of varieties of methods of bonding plastics together. And again, I'm concentrating on RF welding, but I want everybody to understand that there's no one process that's perfect for everything. So you could use impulse welding. Impulse is a great process. We actually use it in our facility as well. When you're dealing with really thin materials and you only have to have a short cycle of taking a nichrome wire and producing heat to push the heat through the 2 layers of material and basically melt them and bond them together. Ultrasonics. Ultrasonics is a fantastic method of bonding materials together. It's definitely an advantage over RF welding, especially when you're talking about rigid plastics. Ultrasonics actually uses vibration or a horn, and that vibration causes the molecules to excite and heat and bond together. There's a couple experts here in the audience that probably could share a little bit more with you on that from Branson over here, so feel free to ask them some questions on that because it is a good process. Adhesives. Everybody knows what adhesives are, other than just Elmer's glue. But gluing and adhesives are another way of bonding processes, but you have to add those components to the layers of materials. You have laser welding. Now, laser, I'm definitely just smart enough to be dumb about that subject. But in the laser process, you actually have the laser that passes through a clear layer of material and goes into an absorbent layer of material, which is where the heat is created to bond the 2 layers of material together. Sewing, everybody knows what sewing is. It's a great process and a really strong process, but it does puncture holes in the materials. And then of course you have radio frequency, which is where our expertise lays. With radio frequency, what you're actually doing is you're taking a combination of time, heat, and pressure, and the radio frequency, which is 27.12 megahertz. You're passing that energy through the film to create the weld itself. So if you can imagine, my 2 hands are 2 pieces of materials. The palms of my hands are the middle of the 2 materials. When the RF die comes down on my palms onto the top of my knuckles, the heat is excited from my palms and it heats from the inside out, kind of like when you're cooking a potato in a microwave. You're heating it from the inside out, so hopefully you're getting the strongest bond possible because you're melting the materials from the inside out instead of trying to heat it from the top down through to the bottom layer. So, there's many advantages from all the different heat sealing systems. There's also disadvantages for every single system, and every one of them has its own challenges. If you take impulse welding, well, impulse welding is great. Some of the limitations to impulse welding is when you actually have a straight line. So impulse is hard to do in rounded shapes and corners. You have ultrasonics. Ultrasonics, like I said before, is really a fabulous processor of rigid plastics. I'm not aware of it being as flexible in the thermoplastic flexible film category. Adhesives, they are application dependent. Sewing, very strong like I said, but not airtight because they're puncturing holes. Laser is a good process, but again, you're limited on the selection of materials because you have to have a clear and an opaque to absorb the laser. And then radio frequency. Radio frequency being, of course, what, I'm biased, of course, but I think it's a great process. But it currently, without our technology, is limited to polar plastics. So why would you want to choose radio frequency over any of those other processes? Well, every process has its own limitation, and every product, whether it's material-based or the design of the product, will help steer you in what direction is best for what type of process you're going to use. But why you'd want to use radio frequency welding is a good start is complicated shapes. If you can draw it on a piece of paper, any 2-dimensional design, you draw it on a piece of paper, we can actually have a tool made in that design. So if you see this picture that's on the screen, I hope everybody can see that okay in the back. There's actually 4 components, and they're kind of in a, let's call it a little fish shape. But that fish shape is something that is, the tool is actually designed in that shape. And wherever the tool touches the material, that's where the weld is actually going to take place. So the design of this, of the tool itself, the weld lines are going to follow the perimeter around here and outside here as well. In the design on the bottom piece, you see that all the welds are in the middle of the face mask itself. So again, you can make as many patterns or shapes or designs that you want to. The RF die is going to weld that all in one step. It's great because it can make small formats like a nasal bladder. It also can do very large formats. You can actually weld an entire king air mattress with one cycle. In our facility, we have jobs that are set up to where we can actually switch from one job to the other probably in about 30 or so minutes because of our enabling of the machines to take tools on and off of those machines. And then, like I said, you can do a wide range of polar materials, and then varying weld widths, which enables you to make the size of the weld bigger if you want to cut through it to cut off excess, or smaller if you have a smaller product like a nasal bladder. So why eliminate PVC and polyurethane? Well, first clarification that I want to emphasize is that PVC and polyurethane are great materials. They've been used for a long time. We use probably 70% of the materials that we use in our contract manufacturing business are PVC and polyurethane. So I'm not saying that they're not good materials. We're just hearing from the market, and we're getting requests to find solutions around PVC and polyurethane. PVC, from the standpoint that there's some environmental issues that are being publicized that people are trying to get out, government issues that they're trying to get around. DEHP, and I'm sure you've heard of a few others that I don't need to necessarily get into the technical battle of why those are not good polymers to use, because I still use them. So that'd be kind of speaking out of both sides of my mouth. Polyurethane doesn't have as many issues from the environmental factor as PVC does. Polyurethane's a great material. It's bulletproof. It's one of the best materials out there, but it's also one of the most expensive materials out there. So that's a little bit of the challenge with the urethane. People are trying to find something that's almost as durable, but yet just a little bit less costly. So how do you get out of PVC and polyurethane? I know this is the whole event's around this one slide, and you're going to see some information here that you probably already know, but I want to specify just a little bit more. One way is to take a material and blend resins or put in additives into a resin. That's a way to get around it. Everybody knows that EVA is something that can be welded just like PVC. So you can take a low density polyethylene, and you can blend in some EVA and put in enough EVA to make it RF reactive. It's the EVA that's making the resin-based polar, which enables it to be welded with RF. The problem with adding EVA is that if you put in about 20% EVA content, you could raise the actual cost of that LDPE base by 18 to 25%. So you're really kind of going backwards from the opportunity, because PVC is inexpensive. You don't want to get into a higher expense material to replace that material, at least with the market demand the way it is. Another challenge about adding EVA, again, EVA is a good material, but EVA also can add other problems back into the polyethylene. Moisture vapor transfer rate is an issue with EVA, because it's pretty easily, moisture and oxygen pass through the material fairly simply. It could also add taste barrier issues. If you have a hydration bladder or something to that fact, it actually puts not a pleasant taste into the water itself. And then EVA is also difficult when it comes to processing. If you have any RF equipment and you're using it on a regular basis, you stick EVA into that process, and over time it starts to get sticky, and it has to be set at just the right temperatures to keep it from being too blocky and sticky on the dies as it's being processed. Another way to get around PVC is additives, adhesives. Adhesives are great, but now you have an added cost of the adhesive. You have another process that you have to add, and they can be messy, and cycle times can also increase. Finally, I want to talk to you about another solution, which is Ecogenesis. Ecogenesis is something that we have as a proprietary technology. It's what, of course, I can't tell you the whole secret sauce of the technology, but it's a bolt-on technology. So you can take any standard RF equipment that you might have in your facility, and you can actually add our technology to that equipment and switch from welding PVC 1 minute to welding polyethylene within 30 minutes, just like about the time to switch out a tool is about the amount of time that it takes to take technology on and off the machine. So our proprietary technology allows you to be very flexible in the use of the RF welding equipment. The great thing also about that technology is it brings in the ability to weld even thinner materials than normally welded with RF, which thinner materials can be a challenge in the RF field, because the arcing process starts to take place when you don't have enough meat, so to speak, enough of the material between the dies. And then you don't have to use any adhesives with Ecogenesis. There's no additives in the films, so the films can be virgin monopolymers just the way they come, or they can be any blend thereof, but there's no requirements for what's in the material to make it polar. And there's no leftover residues, and there's no expensive blended films to look back for. So the great thing about the technology, it lasts tens of thousands of cycles, and it doesn't leave any of those residues. So that's the basis of our technology and what allows us to take our standard RF welding equipment and go from welding polar materials to non-polar materials. Those materials, again, what I listed before with standard RF, you're limited to PVC and polyurethane. But with Ecogenesis, we of course are able to weld a lot of other non-polar materials. And there's a lot of materials yet that we haven't even tested yet. There's some things that we're getting into in the market involving bioplastics. It's a very unknown world of plastics where they're starting to add starches and other components to make it a little less carbon footprint. And those things are being developed, and we're trying to get a hold of some of those to see how our technology works in that material and see if that's something that might be viable in the future as a lower carbon footprint material. So with that, that's about it for what I have to present today. If you have some more questions, I'd like you to visit us at our booth, of course. I'd like to open up the floor for a couple questions right here, right now. But if you don't have time for any questions, please make sure that you see my sales manager, Mark, in the back. I'd like to give everybody a handout that has some non-polar materials. We have some suppliers that provided us some materials that are non-polar, that are some new stuff that are coming out, that we actually have welded samples to give to you. Some from Technor Apex, Alstrom, Oliver Tolis, and Wyman. Plus there's many, many other materials back at our booth that we could show you as well. But that's a handout that you can have. So with that, I'd like to open the floor to see if there's any questions. Well, no questions is not a bad thing. Can I challenge it? Yes, sir. What's the basis of our technology? Well, that unfortunately is a question that I can't answer because it's a proprietary technology. It's not something that we have patented because it's something that can be reverse engineered. So we've actually kept it trade secret by keeping it proprietary. So instead of patenting it and publicizing it, we keep it proprietary. And then when we license to somebody, they get a license agreement. And part of the reason why our customers keep the technology secret is because, again, it's an opportunity that they have that maybe their competitors don't. So they don't share that information. So I do apologize that I can't answer your question directly because that is part of the trade secret. Any other questions? Yes, sir. We can do a tear seal in most applications. Not every application. Sometimes it's material related. On a polyethylene, yes, sir. Polyethylenes, metallocenes, TPEs. Some of the TPEs are getting difficult. Depends on how close they are to the structure of a polyurethane. Polyurethane is something very difficult to tear seal, even without technology. Good question, though. Thank you. Anybody else? Yes, sir. Let me make sure I understand your question. What is a non-polar material that is equivalent to a urethane as far as properties is concerned? I'm going to give you my feeble answer to that, but I would refer you to companies like Technor Apex or Wyman or Oliver Tolis or Alstrom or Poly One for further answers on that. But I've seen a lot of engineers working with TPEs, and some of those TPEs are, they're taking that material and it's much stronger than PVC. So it's right there in the beginning. It's better than PVC, but it's getting closer to polyurethane. I don't think they're as good as urethanes yet, but they're getting closer. So, excuse me, sir. TPE, thermoplastic elastomer, metallocenes. Engineered polymers that are called TPEs. Good question, thank you. Anybody else? Okay, well, thank you very much for your time. I appreciate it very much. Again, don't forget to check with Mark and get some of your welded samples. Thanks a lot.